Assalamualaikum warahmatullahi wabarakatuh. We are from class CDCS 1115A. Will be presenting our group project about waiting line and queuing theory. For this group project, our group chose to do the observation at Tealive. This is our group members: Nur Hanis Irdina binti Muhammad Saini, Nuratyka Dalila Natasha binti Roslan, Nur Aliyah Zuida binti Muhammad Azmi, and Nur Hadhirah Safi binti Muhammad Hanafi. 1.0 Introduction. Tealive is one of the most popular drink outlets. Tealive provides a modern and convenient experience, making it a great place to relax, take a short break, or spend time with friends. The Tealive outlet that we choose to conduct the queuing system is located at S4 8A AEON Mall, Jalan Jambatan Sultan Yahya Petra, Kampung Sireh 15050, Kota Bharu, Kelantan. Tealive AEON Kota Bharu operates daily from Monday to Sunday at 10 a.m. to 10 p.m. following the mall's opening hours, so it is convenient for customers to drop by at any time of the day. For our observation, we choose the period from 12:30 p.m. to 1:30 p.m., which is usually a busy lunchtime period. We also noticed that the outlet has only one server managing the orders. Here is some of the photos and videos that we take at the Tealive outlet during our observation. 2.0 Characteristics.
There are three characteristics of arrival, which is size of calling population, pattern of arrival at the system, and behavior of the arrival. For size of calling population, the size is infinite because the Tealive serves the general public and there is no limit to the number of potential customers who may visit Tealive. As for pattern of arrival at the system, the pattern is random arrival. The customer arrival follows portion distribution, which means customers arrive unpredictably and do not have a fixed schedule. Lastly, behavior of the arrival. The customer arrival behavior is patient. Customer willing to wait in the queue until they receive their service without leaving the system.
Next, waiting line characteristic. In Tealive, the length of a line is unlimited, which means there is no limit for how many customers could come and wait in queue. By definition of unlimited in queuing theory is that the waiting space is so large that it never reaches maximum capacity and the customer could come at any time they like without reaching the maximum space. Now, for the queue discipline is identified as FIFO. FIFO stands for first in and first out. This is where the first customers that wait in line and order their desired items is going to be the first person to be served and receive their order. Moving on to service facility characteristic. Number 1 is the number of channels. In Tealive, the number of channels is a single channel system where customer only interact with one counter. Next, the number of face. Tealive has a single face system. Although while we are surveying, we spotted 2 staff and 2 counters at the Tealive shop. The first counter is where the staff took order from their customers, while the next counter is where the customers received their order. However, while we are surveying, we saw that the order and preparation are happening at the same time. While staff A took order from customers, staff B began immediate preparation. This kind of service were maintained consistently throughout our survey. And since their service is really fast, this means that customers only interact with one counter and one face only. This is because customers only come up to the first counter and order their items and pay, and also receive their drink at the same counter again. Lastly, the number of waiting line is a single line. Moving on to basic queuing system configuration. In Tealive shop, they are using a single channel and single face system. This kind of setup is very common in beverage shop. It is implied that customer will queue in a single line and go through a single counter only. In Tealive, we are able to see that customers queue in a single line and interact with a single counter only. When customers state their order, the service begins immediately. And in such a short span of time, the customers also receive order from the first counter that they ordered earlier. Thus, this means that Tealive has a single channel and single phase system.
2.5 Queuing Model Calculation. To find the arrival rate, the total customers arrived at Tealive during our observation time is 20 people, so our lambda is 20. Next, to calculate the service rate, first determine the total service time for 20 customers. The total service time is 1558 seconds, which we convert to minutes by dividing by 60, we get approximately 25.97 minutes in total. To find the average service time per customer, we divide the total time, 25.97 minutes, by the number of customers, 20. We will get the average service time is 1.30 minutes per customer. Then, to find the mu, we divide 60 minutes by the average service time per customer. So 60 divided by 1.30 equals approximately 46 customers per hour.
From the previous data set, we know that our lambda is equal to 20, which is the number of customers arrive in 1 hour, and for the mu service rate is equal to 46 customers per hour. Since the server at Tealive has only one server, we will use the formula for the single queuing system. Firstly, we need to find the average number of customers in the system. We use the formula L equals to lambda over mu minus lambda. Then we substitute our lambda and mu value, which equals to 20 over 46 minus 20. Then we will get 10 over 13, which equals to 0.7692. That means we will round it up and we will get the average number of customers in the system is 1 customer. Next, we calculate the average number of customers in queue using LQ equals to lambda squared over mu times mu minus lambda. After substitution, we will get 20 squared over 46 times 46 minus 20, which equals to 0.3344. Round it up and we will get the average number of customers in the queue is 0 customers. Next, to calculate the average time a customer spends waiting in the queue, we use WQ equals to lambda over mu times mu minus lambda. After substitution, we will get 20 over 46 times 46 minus 20, which equals to 0.0167 hours. If we convert it to minutes, we will get 1.002. Hence, the average time a customer spends waiting in the queue is 1 minute. Then, we calculate the average time a customer spends in system using W equals to 1 over mu minus lambda. After substitute, we will get 1 over 46 minus 20, which equals to 0.0385 hours. If we convert it to minutes, we will get the average time a customer spends in system is 2.31 minutes. After that, we will calculate the utilization factor. We will use rho equal to lambda over mu. After substitution, we will get 20 over 46, which equals to 0.43. This means that the probability that the service facility is being used is 0.43%. Lastly, we calculate the probability that there is 0 customer in the system using P equals to 1 minus lambda over mu. After substitution, we will get 1 minus 20 over 46, which equals to 0.57. This means that 0.57% that the service facility is not being used. This is the output from QM windows regarding queuing system in Tealive Kota Bharu. The server utilization raw is 0.43. The average number in the queue is LQ 0.33. The average number in the system L is 0.77. The average time in the queue WQ is 1 minute. The average time in the system W is 2.31 minutes. Lastly, P-null is 0.57.
Is the number of servers provided adequate? Yes, the number of servers provided is adequate. Since the rate of customer service exceeds the rate of customer arrival, Tealive can serve their customer on time. Are the customers happy with the waiting time? Yes, the customers are happy with the waiting time because the waiting time in the queue is minimal, which is just 1 minute, and the customer won't have to wait for too long to be served. What have we learned from doing this project? We learned to patiently wait for the customer's arrival and collect real data. We also learned how arrival patterns and service rates affect waiting time. Lastly, we learned how to utilize tools such as QM windows to efficiently analyze and interpret the data.